Hey everyone, I'm finally back after a 6 or 7 month break and I'm super excited to get back to it. Over the last few months I've been balancing a lot, other commitments, and I've had an ever growing interest in Python. I've made quite a few different projects then in this year alone, 2024. If you're new here, I do Python tutorials from basic to advanced, along with tips and tricks videos, and pretty much anything you can think of when it comes to Python programming. Today I'm coming back with a bang. In this video I'm going to showcase all the Python projects I worked on throughout 2024. I think there's about 14 or 15. Setting programming projects for yourself, whether big or small, is such a powerful way to level up your skills, apply theory, and get real world practice. I did also write a Medium story about it as well. Check that out, it'll be in the description, the link. Now let's dive into each project I've done this year and the cool things I learned along the way. As mentioned, I've done quite a few projects over the past few months. I did say about 14 or 15, so I'm going to break them down to categories to make it easy to follow. Just before we resume, I did say in the intro that it's been 6 or 7 months. Well, now it's been 9 months. Yeah, I've spent about 3 months making this video, over 100 hours of editing. And so if I know it's early in the video, but if you could like and subscribe, it would make my day, and it would in fact it would make my year 2024 then if this video did well. Anyway, here's the contents on screen. You see I'll put them as chapters as well probably. And let's get into the video now. Hope you enjoy. And let's start with some maths related projects that helped me with complex problem solving. For example, the first one is the numbers list controller. In February of this year, I developed a small practical tool that can manipulate lists of numbers in multiple ways and store the results in a file when the program is closed automatically. I made the first version as a default command line app in Python, where the user chooses from an option menu and enters in the numbers, how they want to manipulate the list. I then also proceeded to make a Tkinter version with a GUI for ease of use. This project was just like a small, fun little maths related tool that I came up with and has been useful since. To be fair, there weren't really many changes in implementing this, as it was quite simple and relied on basic file handling, list manipulation techniques, things like that I already knew in Python. So that was just the intro. It has been running in the background then. We added number 5 to the list. We don't want to add any more numbers now. Now you can view the first number, remove the first item, and view the first again, and that's different now. Number 4 will add another item to the list. By the way, this is only numbers that you can add. I think it breaks if you try and add anything else. But we'll add some more numbers as well. Then you continue adding numbers. Add another one. Which number? 90. And last. Yeah, now we can view this full list. So now it's quite a decent amount of lists. Then number 5, we remove an item and remove another one. And we view the first one now, that's 15 now. View the full list. Think it might exit now, yeah, we exit. So now it's saved in numbers list 6. And if we get that open now, here it is, numbers list 6. With all the numbers that we had in that. So now let's open the Tkinter version, which has a GUI basically. And it has a custom file save and file open methods then. So you can see the code all there. There's not much more code than the previous one. So now we're going to load the list. It's just in this folder, we got a few different list files then. So we're going to open list 1. You see there 1, 2, 3, 4, 5. And if we add to the list, for example, it adds it at the end, remove from the list, removes from the start. Kind of like a queue data structure then. Large multiple of the same number, 56. Add some more then. Remove some more. And now we save it as a previous. I think we might overwrite list 4. No, not gonna. Or list 2, yeah, let's overwrite list 2 then. And so then if we load a different one, so let's say we loaded list 5, or I think list 5 is broken. See, that was indeed numbers list 5 that was broken. You could see in here there's spaces between the numbers. It doesn't work like that if there's spaces. So we go back onto it now. We'll load a different one instead then. Load list 4. That was 5, 6, 7. You can see that there. And now we load back the previous one, list 2. You see all our numbers are there that we saved. We like remove 4 from the list. We can add it back to the end of the list. Now then, yeah. And I think we'll save this then. Save it as a new file then, new list. Different list again. We load list 1 this time. That's 1, 2, 3, 4, 5. And then we load a new list. You can see all the stuff is there that we just saved. And so that was the numbers list controller, just like a simple tool, definitely useful then. Project is the goals challenge outcome calculator. So fairly recently I had an idea to come up with a calculator for the footballers goal challenge I've been watching a lot of recently on YouTube. I regularly watch Razem Atazah failing the 10,000 goal challenge, but I also watch some other ones, and so I thought I'd make a calculator to simulate the best possible, worst possible, average outcomes and more. Also, I've seen others doing a similar thing, like the best possible, worst possible calculations, for example, and even someone doing it with a custom bot they built. So I knew I had to give it a try then. So my calculator additionally included 6 options for the amount of goals, each with their own set of multipliers. But quickly expanded then, so at the moment I think it's got 10, but there is room for more as well, since I think there is 1 or 2 more I've seen down in there. So basically it sorts the list by ascending order to get the total best possible outcome, and then descending order to get the total worst possible outcome, and outputs it in a user-friendly format. Then it also uses the previous history, which is stored in a text file, to output the amount of attempts so far, the ranking of this attempt, the difference between this score and average, and also the current accuracy, average accuracy. All of that is in the user-friendly message as well. And so that was the intro. Now we're running it. We will get back to that explanation and stuff afterwards, but now we just start entering random player names then, and like random amount of goals. Then I can just show how it works first. So for this, I just manually enter in the goal. I do it based on the video that I'm doing the calculator for. So I look at the video, then put in the goals with the multiplier then. So it shows it with the multiplier in the video, whoever's doing it puts the goals with the multipliers in the video. So I just write it from there then the same, and the same player names as well, of course. The reverse mapping for the player names so that they're associated with the goals, the raw goals, so without any multipliers rather than anything else then. And so then we get all this output. But this version has some stuff printed out as well that we don't really need. but that's like the user-friendly message at the bottom. And then we've got best possible result and worst possible result there, a breakdown of it. Actually, this is like before we change the message then. Yeah, we added this combos display then. So that does a user-friendly message, a more user-friendly message then, based on the feedback we got. And in this version, we got 10 different options as well then. We mentioned about the 10 options before. This is like version 2, I think, or maybe version 1 point something. Then, yeah, we're just entering random player names as well. Obviously, these aren't actual players then. I don't know. Yeah, so this one we're doing for 90,000 goals, aren't we? Kind of a interesting test. Haven't actually used 90,000 goals before, I don't think. It's one of the more recently added ones as well. I think when we save it to the history, you say 1 out of. It's a bit harder to think of values, I think. Anyway, this is then 6,400 there. Just like random values, random letters for the players. Just skipped a bit now since it was just that longer laborious putting in the values then. So we're like near the end of the 90,000 ones then. On multiplier times 9, I think the highest might be times 10 for this.
No.
Or it might go higher. Multiplier times 10. Might actually go to times 11 for this one, I'm not sure, but I think this 90,000 one actually had one of the most amount of players in there. We're still not at the end of this. Still got some more to go. Thinking of times 10 multipliers is a bit easier than like times 7 or times 9 or something like an awkward number like that. Times 10, you just have to add a 0 at the end, don't you? And still another times 10. I think, yeah, this, we definitely should have chosen this one then. I was actually thinking about cutting this bit out before, I think, but we keep it for now. Yeah, times 11 now. Entering random stuff still. I think we did do one with the random number generator as well for the numbers that might have been after this then. Another times 11. How many players are in this one? 9,000 goal, 90,000 goal challenge. Okay, now we got the output. And look, you can see it's way more user friendly than the previous one. And that is an insane amount. And at the end, history saved successfully as well then. 90,000 goals. Congratulations, you achieved it. I then, in the most recent version, I introduced an automatic clipboard feature to copy and paste the summary. But for some reason, it doesn't work on phone, but on my desktop Python version, I have that then. Now this is the version with the copy paste functionality, the next one. Well, like, I think this is the latest version then. Overall, it's been quite a profitable project, receiving loads of likes on the comments, even directing people from those comments to my own videos on my FIFA YouTuber channel. Also helped that the person who coded a custom bot went on holiday and I ended up taking over. He said he would be gone for a week and a half, but he's still not back. Don't know then. And also recently started doing it on Instagram as well because he uploads the videos to Instagram before YouTube, apparently like 2 or 3 hours before. So it's been really good on Instagram as well. The replies that I get for the comments are mixed usually. Sometimes you get replies, bad ones. Sometimes you get good replies like praising me, and then sometimes it's a mix of the two. But some people do then defend me in the comments. And since I do it like almost every day, there's people who've seen the previous comments as well then. Yeah, and so now I'm running the version 9,000 goals, doing the version with 10 different goal targets, possible ones. And I think this is the one with copy paste functionality as well then. So it'll automatically copy it to the clipboard and then we can paste it in. I'll show that then. So I think we're generating, yeah, we generate random amounts of goals here then. Bro, 4. We were, yeah, so we're just going along, just like random letters for the player names, and then with the goals with the multipliers. So this one's a times 4 then, quadruple multiplier. And we entered the goals for the player name by accident there as well. We did it a bit further up as well, I think. Yeah, so then we get the everything there then, and we can paste it into a blank notepad. You see there, it's all there, the bit that we wanted. The bit from the top where we did the inputs is not there then. And so yeah, that was the goals challenge outcome calculator, a bit of a long one, that one, but next one is shorter then. Do stay tuned then because there are more exciting projects coming up. So next was a complex random draw. So another project that's quite recent and that's mass related, is a complex random draw resembling, but not limited to, the new draw adopted by the UEFA Champions League and other European competitions in football. If you follow football, you might know that this year the format of these European competitions was changed, and it was announced the draw would be way more complex with most of the work being done by a computer algorithm. This prompted me to make my own version of the draw and challenge myself to do this with any help from web resources, AI generated code, or Google searches. It has proven quite a challenge as I'm having to rely solely on my prior programming knowledge and coding ability. And I did do quite a bit on it, but then since I have been putting it on off quite a while, I originally did plan to finish it before the UCL draw. I think that was like September, but I was unable to do so, and I've been putting it off so much then. It's now nearly halfway through October, and I still haven't done that much on it. It's still not finished. So I'd say it's more than halfway, but I do plan on finishing it in the near future then. That was like another overview of the situation and why I made this. And so now getting into the actual code, you see I made the different arrays. We used for loops to put the stuff in, so we're splitting the team teams into different pots and then adding all of them to the countries dictionary. We got multiple in the teams at the bottom we showed before. We got multiple dictionaries in there, but then we don't need yeah. So then we use a few different loops. Just get a bit inefficient. I think there would be a more efficient way of doing this, but for now we'll use that and maybe change it afterwards. So we're checking the home games and the away games separately. We're going looping through the different pots. Well, only one pot so far. checking previous matches and stuff like that as well. And at the end, then we're outputting it each match, and then we need that to check the team as well. So the home team for that match, and then the next two matches will be their match. You see when I run the output, and so we got all these parameters and stuff to make it like really flexible then, and to try and mimic the actual thing, but also much more than that then. So we haven't like finished this, as I said before. Still quite a bit more to do, but if we run it now, we see we have all the different teams, and then if a match is already decided, like for example Real Madrid versus Inter, if you go down to matches for Inter, Real Madrid versus Inter comes there as well. So if a match is already in the previous matches, and it'll come again in that team's matches, then Liverpool versus Barca. Yeah, so we need to be able to lock up the teams as well, but it's mostly done. Move on to the next thing. The next project is the work hours calculator. This is the last project from the maths related category then. So recently I underwent a summer internship. I did post about it on medium.com, and I linked the article on my YouTube as well. I found that through university. So during the internship I wanted a quick way of logging my work hours and finding out how long I'd worked across a number of days that weren't confined to like the different days of the week, but like any days I worked. So like from day one, so like you could add a day up to like day 10 or day 15 or whatever. So I ended up making two different versions, a version in Python for my own personal use, which obviously I'm going to show now, and then a version in Microsoft Power Apps to share with work colleagues then. And so the version in Python, well, both versions have three different apps in one. You could say a basic app where you can input the where you can copy paste, where you can paste the full string. That I used to, similar to the one that I used to paste in my calendar. I used to write in my calendar every day. And then there's okay, so that was like the description of this project. Now we're in here testing it, showcasing it. So we press end there because the hours was already a whole number. So then we're gonna paste a similar string again for that, but we're gonna change it this time to different hours then. So we change it to 5 o'clock and like 9 o'clock start. And lunch we might change as well. We leave lunch the same. So now we've got 7.5 hours, haven't we? Yeah. And so then if we wish to view it in hours and minutes format, which we will, 7 hours and 30 minutes, that is. Now day 3, doing different hours for day 3 then. And so we went to the example work hours for day 3, and then now we won't view the hours and minutes format, and we won't add any more days, and there's our total and average overtime as well. Or the GUI app version, which is obviously the most user-friendly version then. So we got it open now. We're gonna enter the contracted hours and like start time, end time, lunch, start, lunch, end, and we add remove days as well with the buttons. And it looks like quite a good system then. So it's similar to the previous one. There's even tooltips added in yellow. Those are like an additional window overlaid onto this. So we enter 6.5 hours and we do per day. So start time. So we do 8:30 start time. 16:30 end time. Lunch start 12:30, 13 o'clock for lunch end. Add another day there. Now we got day 2. We write this times for day 2 now. 9 o'clock start on day 2. Let's say you see the tooltips there, they're different for each box. Obviously for each of the same box they'll be the same but different. End time 5 o'clock. Lunch start 1:15, end 2 p.m. Then on day 3, let's say we started at 9:30, ended at 5:15. 1/2 lunch. Lunch end 2. We calculate and nothing happens, lol. I think it's broken. Okay, and so now we're back. There was indeed an error. We can't actually use decimal numbers, but now we use 7 and we can see all the stuff in there that was presented in the previous app as well. 22 hours total, 7 hours per day contract. And we press the clear button to clear it as well then. The file upload version where you can specify in Python you can specify a file path where the work hours are stored and you read from that file. So then we can see then we got tells us our total hours and then the overtime as well. And so now then we'll move on to the useful tools section. Next we'll move on to some useful tools that can help me and others with tasks, mostly automation tasks, such as then the random currency generator I made. So recently my dad tasked me with making a profit loss calculator for himself. So I made this spreadsheet in Excel then. He requested that I wanted a spreadsheet then. I wanted a quick and easy way of generating the random numbers to fill in the currency examples for testing purposes, such as on that sheet then, that's the example sheet. So I came up with this random currency generator where the user enters the upper and the lower bounds for the random generation and then how many numbers they want. So then starts to generate the numbers between those specified ranges as decimal or float numbers to 2 decimal places. I use the ingenious method here of combining the decimal random generator with the integer one to get decimal numbers in between the range specified. You can add them together and round it then. Also then copy the numbers to the clipboard with a 2-second delay to then in between each number, then you have time to paste it in. It's very useful for me when I was filling out the spreadsheet with examples and I could see many other uses for this as well then. As you can see there, we accidentally pasted the same number, but we just pasted it again to resolve it and it was the next number then. We did 20, but we only needed 15 numbers, so it's still going at the end. But that was just in case we missed some, and now it's finished. Oh, that was just a small little tool then. I was thinking about putting that in maths related tools, but then I moved it to useful tools instead then.
Just a reminder that you can view all these projects on GitHub, especially if you want to use them yourself, either as a tool or to study the Python code. Link is in the description.
Next, we come on to the Python file counter. In April of this year, I developed a small tool just in the default Python command line that can search a directory and all of its subdirectories for a specific type of file. This can be improved, of course. I can think of maybe 2 or 3 different ways to improve it. The obvious being like having a dictionary mapping of file types to extensions. As the moment the user has the extension and enter the extension of the file, but maybe the file type could be used instead. For example, Microsoft Word instead of docx. But other than that, it's quite a unique idea. I've never seen a file counter that counts the amount of files of a specific type in a directory and all the subdirectories. So now we're on the thingy. We got a root directory as the input and the file type, and this method is counting the files. So it's using os.walk and stuff like that. That's like the description of what the program is doing. Those comments there. Then we've commented out a print file. Obviously, you don't want that all the time. Then so we enter a file type in, for example, py for Python, and we count in this directory dot, and you can see 960 Python files. I do have quite a lot. and that is actually a verified number as well. I've checked that before. So it does work properly. And so then we can rerun it. This time we might use a different, we search for txt files in here as well in 74. We would specify like a full directory path as well, can't we? So if I enter a different file type, come back, for example, docx for Word, we go to documents. That needs to be the exact file path, doesn't it? We can search exe in program files and we see that there's 371 there executable files in the program files. Next, we have the Leetcode solution searcher. Also in April, I was completing quite a few Leetcode solutions. I'm probably going to do a video on Leetcode soon. And I found that it would be useful to have a tool that could search through previous solutions for problems that I had completed and then give me the code for that problem. And I could also see where I could reuse some code as well. Obviously, it would be useful for other people as well if they use solutions from my solution bank. So then I made this where you can just enter in the number of the problem. All problems show a number, such as 2444. And if it exists in my solution bank, it output the full Python code. Pretty handy trick, and you guys can try it too. At the moment, I don't have that many solutions stored in there. I think only 4 or 5. But I'm working on adding more soon then. I could also maybe make a version for other programming languages as well, like Java and JavaScript as well. That could be one for the future. We'll have to see about that then. Okay, and so we're on the Python code now. You can see on the left the solution searcher, and then on the right is the Python file with the solutions in there. So I'm not reading the solutions from text, I'm reading them from actual Python file as well that contains them. So then you got our mappings of the solution numbers to the actual methods is finding in there. You got input then for the number, user input, flag variable for solution found. And if the solution is in the mapping, then it's gonna search. And if it's found, then it's gonna give us the data until the next method. If the return's not in the line, or if the definition is not, I think it'll stop then. Solutions as follows. So if we run it now, check the numbers that we've got. So 992, for example, says squeeze text. If we open that, it shows all the stuff. Oh, start showing all of them. Why is it showing all of them? It's only meant to show one. We'll do more work on it in future, but it's not meant to do that. Not a syntax error as such, it's more like a logic error, isn't it? It's not the intended result. Nothing's broken, but it's not like the. If you do that at 101, it shows, yeah, there were only 2 methods, but then those 2 at the bottom, that's why I think. Because there were so many different constraints we needed, maybe we ended up doing it, showing too much then. 3784. Once again, it shows that method and then everything underneath it as well. That was the is good one. It's only meant to show that, isn't it? It's not meant to show those 2 at the bottom. So yeah, I would have to do some more work on it in future then. But that was the Leetcode solution search. Next is the WhatsApp poll configurer. Fairly recently I had the issue of having to duplicate WhatsApp polls. So basically there was something that me and my friends were doing in our group chat that required the same or very similar poll to be sent every week. So I came up with an idea that an image of the poll could be used to either send a new one automatically or help automate the creation of a poll by periodically providing the user with the copy-paste options from the original poll to speed things up when creating the poll then. It turned out that the first version wasn't actually possible, as you can't send a message of the poll to WhatsApp directly through Python. So then I asked ChatGPT for a quick overview and then started coding it. It uses pill image libraries and PyTesseract to read the text from the image. It then utilizes Paperclip's copy functionalities to add the options to the clipboard. It also utilizes PyAuto GUI's hotkey functionality to automatically paste it in at intervals. I managed to utilize it then to duplicate a poll perfectly in WhatsApp after some work and different testing methods. However, I tried it with another slightly different poll and this time it didn't work properly, so it probably still needs a bit of work. We'll get there soon. It'd be a great general purpose tool then for copying all kinds of polls just by inputting a screenshot via the file path. So here we are on the code. I've already shown some snippets of it in the intro section of this project. So then we've got it here. We're going to run it now, I think. Yeah, we run it from there. First we enter the path to the image file, which is just stored in the same folder, so we don't need any. We just need the name of the image, so test poll2. See, you pasted that in. And a bit before, never mind that was from a previous test. You see it goes down automatically and pastes in automatically. Thingy. Don't know why I put 2 in that same one. I don't know what that thing is at the end. But we can that and put it at the bottom then call me. And get rid of the stuff from before. There now. See all the options are there. We can tick whatever we want and select the multipliers on as well for this one. Selected that one. Same as no WhatsApp then. So that was the WhatsApp poll configurer. There's one more project left in this useful tools section, and then we can move into more exciting sections. Then next we have the Markdown to plain text converter. So I wasn't gonna add this one originally, but we have added it now. It's actually less complex than WhatsApp poll configurer, but we added it then at the end now of this section. So we have we're using a Takinter window then in here. We're doing Markdown to plain text conversion where a user can enter Markdown text on the left. So for example, text generated by a ChatGPT or something like that. And then it removes all the characters that make into Markdown. So like say you want to put into a plain text, normal text file .txt. So here you can see it removes the different symbols, removes the hashtags, the asterisks, and the backticks. That's what that symbol is, the last one. And so then it's as if it was plain text originally then. And then you can export it to txt. That this method just here, write to file, which is gonna write the parent text that you could just convert it to a txt file. And then this is getting the file name, so the user can input a file name. Just comment out that print, that was just for testing purposes. Copy text, that was coming before, but I've added that now. It's a bit different now, the thingy, but you can copy the text now. So we paste in an AI generated text here, that's Markdown. We just started generate this generic prompting thing. And then you convert it. As you can see, there's no Markdown characters left now. It's all like plain text. And just write the file name that we want to do. So, for example, prompt test 1. Press export, and then we'll open it in Notepad now. Switch. So here we're in Notepad, and this is the file. All the text that we had converted to plain text then. And you see the preview in there. right text box. That's what's in the file here. So quite a useful tool then. Obviously, the only purpose, it's not the only purpose converting AI code, AI text to plain. But that's the end of the useful tools section. We'll be moving on to the next section now, which is the computer science theory section. Then ultimate category, which involved a couple of projects that helped apply the theoretical side of computer science and make good practical use of it. The next project is the truth table generator. One thing always useful to have when you're working with logical circuits is a truth table generator. I set about making my own highly advanced version that was user friendly and only incorporated one gate but as many variables as you wanted. The one gate could also be chosen by the user from the 6 standard options: not, and, or, XOR, NOR, and NAND. And so here we're on the program. You can see we have the inputs array, which is taking the different combinations of inputs. You have get and a few other variables at the top. Then we have the get input variables, which is using that array, appending to that array, taking user input then. And so then the get input variables array will be used later on. Then there's the get input, which is the same thing but for the gate then. And that one's not storing the gate then, but he's gonna afterwards. So if it's not in the self.gates, then you keep going the while loop. If it's a not, then you'll break because we got a slightly different thingy for a slightly different function for not gates then. So then this is generating the truth table using the for loop. So the for I in range is the 2 times the number of variables and the different methods there then. And then this is calculating, so based on the gate output, based on the gate, what the output's going to be. So for and it's going to be an all for all and any. That formula for XOR, the opposite of the any and the opposite of the all for no and NAND. And for not, it's just going to be the opposite of what it was 1 or 0. We got display function, which is printing out the truth table in a user-friendly format then, using different formatting symbols and stuff. You can see when I run the program, then we have the main here, which is calling the stuff. You run from the main, enter the gate. Then the user could keep entering variables and it produced a table for all possible combinations then, with R being the result or output column. I'm going to do 3 then, no more variables then, and we see our truth table there with A, B, C, and R. Also proposed a more advanced version that could handle multiple gates or even a full circuit, but that never materialized unfortunately. So we'll run it again, you guys should be able to see everything now. A bit was cut off the side before in the recording. So enter XOR, we're doing now X. Yes, there's more variables, Y, no more, and we see an XOR, simple XOR for X and Y. Another one with different inputs. We can see we do a NOR gate this time. Contain our variables. See capital letters work then, don't they? For more variables Y on. That's not case sensitive. You go on 4 variables for this. I think. No, more 5. And that's it. 5 variables then for the. We see how big the truth table gets then. So HAR J AR lowercase r and j as the variable. Well, the variable names doesn't matter then. What matters is the result, of course, for each of them. Then it's the state machine or Mealy machine generator. Now we come on to one of my most exciting and complex projects. I started this in February and it was well into March before I had completed it. You might be thinking it doesn't sound that complex or complicated, but wait till you see it. By generator, I mean from scratch kind of thing, and I did spend countless hours on this scratching my head as well. What I wanted to achieve when I first made this was a program that can take the accepted string of a Mealy machine or state machine with output and then an input string and provide the correct output for the string while simultaneously creating the Mealy or state machine and feeding the input string through it. In university, we were learning about state machines with output, a topic I already had knowledge of from A levels, and thought it would be a good idea if I could challenge myself to make a Python program, one that generates it from scratch to give the output string for a specific input string. I had never seen anything done like this before, and for good reason. It was insanely difficult to automate something like this without giving more information. In theory, the only information that was required to configure the state machine was the accepted string. However, in practice, it was much harder to try and generate one from scratch with only this information. I spent countless hours drawing up diagrams on Draw.io and trying different ways to generate the Mealy machine. I had the main logic part down almost instantly, however it was the finer details that stumped me then. The days and weeks went on, and although it works, it doesn't always give the correct output string. For instance, if I try an accepted string with 5 digits, the end of the output string is slightly wrong. Okay, and so then you can see here that the number that's meant to be zero there because there's no other instances of the sequence. But then, okay, and so if we run the assertions, you can see that there's an error assertion where it says that our time when I had loads of other priorities, I couldn't continue this, then never even ended up coming back to it. Let me know in the comments if there's anything I can do differently. I've probably already tried it, but it's worth a go. Who knows, you might have a different idea that I never even thought about. Well, finally, the last section. Some projects are even more exciting than the previous ones, delving now into artificial intelligence and machine learning, two very exciting and now quite popular fields of computer science. The first project in this section is Funzy ML. So in June of this year, I had an interview with Funzy and they requested that I do a small example of machine learning in Python as a take-home project. I didn't end up spending too long on it then, and 3 or 4 days were given for it. The project was about predicting how many drinks would need to be ordered on a future date based on past sales data. It was just kept simple. There were 4 different drinks that customers would buy, and I just made up my own random data and stored them in CSV files. These could then be processed for the machine learning. It was a step in the direction of AI automation and one that definitely helped my journey in the world of computer science. And so we're running the program now. You can see that we can enter a drink type, then enter the date time. So we've got date times in our CSV files, the data we made up ourselves then. So we enter Monday 8th of July, let's say for example. And time 1 o'clock till 2 o'clock. 1 o'clock till 3 o'clock even, 1 p.m. 24 is the temperature. This is in degrees Celsius, by the way. No promotion, 234 customers, and you see it predicts 344 drinks sold, and this is the data we've got. This is the Fanta one. See a similar date, but then the drinks sold depend more on the temperature, promotion, and customers orders, and yeah. So we'll run it again this time for Sprite. Probably do a different date. Let's take one. We take a date and time exactly from our data set then to use. Yeah. So we copy that date in temperature, we do the same as that as well then. And just stay on the CSV. There was a promotion, 290 as the customers, and we see 472 is the prediction. It's a bit higher than the actual value, but the point still stands. Machine learning used to simulate prediction of drink sales. Next is the AI cover letter writer. So fairly recently I decided to embark on a task to create my own functional AI application that would also complete a task that would help solve a problem I currently had. So a couple of months ago I gained access to Google's AI model Gemini in my native Python environment and set it up then. I completed a few tests on it beforehand before starting this project. My access to Gemini was through my Google Cloud Workspace subscription that I bought in June as a pay-as-you-go plan. As a developer, I would definitely recommend one of Google Cloud Workspace or Microsoft as a possibly Amazon's AWS as well, especially for developing AI applications. I've found Google Cloud Workspace to be easier to use of Azure and Google, personally having done a free trial on both, but everyone has their own preference, of course, then. So here's the app, then the so we got like a chatbot window there using Tkinter, a few different widgets there. We're using the scroll text widget for that, a non-standard one that I had to search up. Then we got some buttons there, send message method, which is providing a prompt for the AI with the relevant context, taking in the resume and job description from the scroll boxes, and then adding the response to the part. And we got some screenshots of it working here of some tests from before. You can see the cover letter from in Word then, and there is a demo then of this from when I originally made it. And so here's the demo. We pasted our CV in the top left and the job description in the top right. Press send now, and you see it's generated the cover letter then for the job description that we put in. We can just then copy the relevant parts, select from all that part, and then we can put it into our Word document. We replace it in this. This is like a cover letter that we had from before we made a copy. Just minor changes needed then. And there we have it, the AI cover letter. Before we get into the last project, a quick announcement. I have opened the Discord server now for mostly for the community fans of my channel that want to join, and also YouTubers can join as well. I've got a YouTubers channel there. Finally, it's the AI testing agent. Now coming on to the last project. This is the most complex project and probably took the longest time to complete. I did mention I did a summer internship this summer, so during the internship I made this AI testing agent to help test some of the software I was making. I made it in Python completely. I didn't have much access to Python at the workplace, but I could do everything, almost everything in the Google Colab notebook. So I originally made it by using Hugging Face models publicly available via the Transformers library. However, I tried a few different ones and at one point they were working, but in the beginning I got quite a few errors because the input text or the text that the AI would generate output was too large for those models to handle. I had to change the models multiple times. I didn't really know much about the Transformers library until I started researching on how I could use AI libraries in Python. I started off with these then, but eventually I ended up settling on using Gemini because I mentioned I've been using it in my native Python environment and I could use it even easier than in the Google Colab notebook. Essentially, this was an idea I had from ChatGPT Agent Builder, and there was a version in Vertex AI in Google Cloud as well that you could build an AI agent. It's like multiple instances of different chatbots like working together, and you could call different specific AI functions like a document extraction function and things like that done, and they would communicate together to try and make a seamless AI flow. I tried to make a Vertex AI originally, but I was struggling, so I decided to go just to Python then. For the main features, first you can input your project name, and that can be used for extra context when you generate the while loop then, which is the main body. That asks for the testing questions. I made it a loop because normally you'd be testing multiple questions for your software at the same time. So every time you import a question, then you could do like a separate test. So when I was testing it, the questions I was doing, I made an AI search in Vertex AI, and so I was pasting for the test question. I was using the question that I used in the search. Ended up making multiple of these AI searches, and then the testing process is definitely speeded up by the testing agent. So I input the question that I put into the search, and I uploaded a PDF. For this demo, I'm using a different data set, a data set of Copilot of Copilot conversations, AI, Microsoft Copilot. The conversations that I've had with that, like exported conversations. I'm using that as the data set for this example search. So you upload the PDF and the screenshot. So like the PDF would be the expected result, and the screenshot would be the actual result then. I'd run the test, and the AI would start generating the summary slash evaluation. There'd be two parts to this then, two different AI generations. The first one would just be the comparison between the screenshot and the PDF document in the context of the tests, and that would be using the testing question. Then the summary would get passed into the evaluation, which was the second AI generation. That would evaluate how effective the test was then based on the previous response and other context. If you've done software testing, you know how hard it is to think of a summary for your testing report at times, especially if the software you're testing is a complex AI search. So the automation of this generation really helped then. It also has a copy paste functionality then, so you can easily copy and paste the evaluation into your testing report. There you have it. After all of these projects, I've learned a ton, from improving my problem solving skills with maths related scripts to exploring new AI techniques. 2024 has been a massive year for growth for me as a Python developer. Each project brought its own challenges, but those challenges helped me sharpen my skills. And so then wrapping up, I'm really proud of what I've accomplished this year, but this is just the beginning. I'm planning to develop more AI applications in the future, starting with expanding on the AI testing agent and the AI cover letter writer. I think I've got planned for 2025 an AI apps challenge. More about that will be revealed in the coming weeks and months. In my upcoming videos, I'm also thinking of working on Leetcode, doing some fun challenges, and even doing a ChatGPT versus Copilot comparison using Gemini. So be sure to like and subscribe if you don't want to miss that. Also, let me know in the comments which project was your favorite or what projects you're working on right now. And of course, feel free to give me ideas for new projects to try out. Thanks for watching. It has been a long one, and I'll see you in the next one.